Well, I'm really enjoying the presentation so far. That's really, really good stuff. My presentation is going to have a similar form to Jeff's, actually. It's going to start at the top at a global level and then drill down. And so I'll begin. The key idea basically is to figure out how we can improve construction productivity using benchmarking and metrics. Most of my career I was building tools and systems and automation from the bottom up to try to improve it. And this is the idea of having a scientific, empirical approach of gathering data and seeing statistically what works and what doesn't work. One of the challenges in doing that is measuring performance, and I'll talk a little bit about that first for productivity and for processes. Then I'll start with this sort of just from an interest point of view, but also policy and strategic planning point of view, international macroeconomic level analysis. Don't be too hard on me, and because I'm not an economist.
Me neither.
Oh, okay. Well, then an industrial sector construction project level analysis. What can we learn from a group of companies in a community, and then what can we learn at the project level by doing activity analysis? So drilling down, right down to the activity level, but applying similar principles all the way down. Then finally some observations. So I have to. A lot of this comes from a research team I work on with COAA. It's my 7th research team. It's a 6-year program for improving productivity. These are all the people I learn from and work with. These are the students who do all the work, do all the research work, and there are a lot of graduate students involved in this, in just that one program. And also some of my Canadian colleagues, some of them here at Calgary and University of Alberta, we work on a Construction Sector Council benchmarking metrics program as well. So one of the big challenges I talked about was measuring productivity performance, and we have had endless debates about this. There's the lot of different definitions out there, so I'm going to go back. And the key thing is you just need to use the right one depending on the context and the people involved. Factor productivity is your economics level analysis at the national level. What we care about on a project usually is labor productivity, but we also care about direct work rate or wrench time, percent wrench time, and performance factors as well. So you just need to be conscious of what measure you're using and use it at the right time. So there's been a lot of studies, and the key thing of just showing this isn't so much to get into them, but that there's a lot of different perspectives on the issue, each with their own set of objectives. These are the different programs from the different countries, and I think I should have included COAA's program, Construction Owners Association of Alberta, but IPA has a huge proprietary benchmarking and metrics program, big internal strategic asset. The World Bank does this. They compare different countries on their construction productivity. They don't tell you that, but they're doing it. Construction Sector Council in Canada and CII, the group that I work with. Very different perspective. CII is a subsector of the construction industry. It drills right down to activity level productivity analysis. And then the Bureau of Labor Statistics, it is very high in industrial kind of national policy level. The interesting thing for me in getting into this the last 15 years or so is that where in IT we work really hard to create integration because it's good for interoperability and sharing and knowledge management. I've tried to push really hard for this in benchmarking and metrics for the same reasons, and I haven't personally made any progress at all, because we have a not invented here syndrome just as much in benchmarking and metrics as anything else. And I just find that kind of interesting. But the key thing so far is that as long as you're aware of all these issues, you can kind of translate between them, the different metrics, and you need to be aware of all these factors. So when you're putting together benchmarking and metrics, you need to understand the different dimensions. There's a performance dimension for project performance in terms of cost and schedule and productivity. And, there's the level of aggregation that you're looking at. There's the practices that you're trying to track, the degree of implementation. There's the there's the time frame, and then there's the project environment. So those are really the 5 different categories that you have to think about when you're building a benchmarking metrics program or looking at the results from a program. You also, if you're going to do studies of changes over time, you have to look at these different indices that help you adjust costs both on the input end for things like commodities cost indices over time. You want to be able to compare apples and oranges over time, or 1990 costs and to 2005 costs. But you also have output price indices that is kind of like, what does a ton of steel cost? If it costs you half what it did in real dollar terms 10 years ago, then you've improved your productivity by 100%, depending on how you're looking at it or not. The challenge in the construction industry is it's the one industry in the U.S. that was never tracked in terms of productivity effectively, and that's partly because they never had good output indices. And the reason for that is that every construction output is different, quality is different, and so they kind of gave up. They had a new housing price index, but in the last 5 years or so, the Bureau of Economic Analysis has been building output price indexes so that they can track construction productivity as an industry in the U.S. More effectively, and they're modeled actually on the Canadian price indices, just as a point of trivia there. The idea is that you have a disaggregate index is you put together kind of a model plant, you have parts of it that are defined very well, and you get prices for them. And you do this over and over again, and that's how you maintain the consistency of the output. And it's really important because, again, I was talking about steel, but you look at a light bulb, you think that that's a consistent product, but if the light bulb today lasts twice as long as the light bulb did 5 years ago, and you're tracking the price of light bulbs, you're not really tracking productivity very well because you've got a change in quality and a change in inherent value. So we have that issue in construction as well. So there's all these just issues swimming around that we have to be aware of. Just as background context for looking at some of these numbers. So I did some research and dug up some numbers, that other people's numbers, and actually some of the last one there is a student who worked for me and myself, and we updated that for the last 10 years. And it's really interesting that it's a big sort of controversial situation in the U.S. where all the data seems to show, based on the crude, very aggregate level government statistics, that productivity has been declining for the last 30 or 40 years in the U.S. Just keeps slowly drifting down in construction, while every other industry is going up. Canada showed good improvement for the time frame of 1961 to 81, kind of flattened out a bit, but still Canada's been showing improvement for the last 30 or 40 years in construction productivity, and with the caveat that this analysis that we did, bottom-up analysis of means cost estimating data for 200 activities over the last 30 years, showed an increase. And what that could be is excluding things like regulatory environment and the, output. But it was kind of an interesting contradiction. It seemed that we're actually performing the work better and cheaper, but why is the industry apparently still declining in productivity? But the update that we did for the last 10 years, just finished student finished the thesis about a month ago, shows that even at the activity level, productivity in U.S. in construction shows a complete flat line for the last 10 years. Okay, so that's labor productivity that I was talking about. This table shows an analysis of multi-factor and labor productivity. Multi-factor is what does it cost per unit output. Labor productivity is how many labor hours does it cost per unit of output. And I really find this interesting because to me Canada and the US are so similar. I've spent about half my life in each country, and yet it looks, based on this data, like Canada has better multi-factor and labor productivity in construction than the US. And as a researcher I find that really, really interesting, because how can two countries that are so similar, why is Canada's productivity better? I'd really like to understand that. I have ideas. You do landscaping in Austin, where I used to live. You've got 24 $8 an hour laborers doing the work. You do the work in Waterloo. You've got two guys who have a skid steer and some power equipment, and they're doing the work. So part of it could just be substitution of capital for labor, and part of it could be the craft training infrastructure, which has been very strong in Canada, but has been pretty much decimated in the U.S. since Reagan brought in the right-to-work laws. So but that's speculation. That's not scientific. I really like digging up these macroeconomic numbers just because I find them curious. So we got some numbers from the Swedish Construction Federation from a friend of mine named Per Oman, who heads up that organization. They've done a study of productivity between different countries. Then we got some data from the Groningen, it's an economics research center in the Netherlands. And that was growth rates. And so what I asked my graduate student to do is plot that. And, you know, statistically this is meaningless. There's no relationship here, but we put a curve in anyways. Because, you know, we can't help it. It's just, you know, I saw that. But so statistically not significant, but intuitively sort of interesting that it looks to be that as your economy is more mature, as your overall productivity rate is higher, then your productivity growth or improvement rate is lower. And yet there's wide range there, right? Having a high basic productivity rate like Canada up there at the very top doesn't preclude growth. So the data, at least this limited set of data, shows that at least it doesn't prove that we can't grow. It is very interesting to me, and the U.S. is the one on the left, according to the data that we have. Okay, so that was. So why did we care about that? Because in my opinion, it helps you think about corporate policy and helps you think about national government policy in terms of craft training, or Alberta government policy in terms of craft training, and also policy about substitution of capital for labor, and you know what labor rates or wage rates are doing to your overall productivity, and then, you know, is a relationship between labor wage rates and productivity. And yes, the World Bank shows that there is. And I just find that interesting. It doesn't mean that the total factor productivity is better. Okay, so that we're drilled down to the productivity at the industrial community or project level. So the reason we're interested in this is so. Before we were just showing big picture macroeconomic issues and what the influences might be on productivity across your whole industry and your whole country. Now we want to know what are the practices, what are the things that work at a project level according to the data. Okay, I'm sure, for example, SNC-Lavalin has all this data, but it's all proprietary. So as an academic, I want to share it with the world. And can we do this based on benchmarking and metrics data analysis? So what we're tracking, at least in our productivity improvement program for CII, is both labor productivity, rework rate, and direct work rate. Direct work rate is a synonym for wrench time. Okay, because I know wrench time is the term we use here in Alberta. Being born in Edmonton, I can say that. So. So we have direct work rate, and we're really looking to improve all these things, at least to develop tools and find out which processes work best for improving all these things. For the productivity hierarchy, the one that COAA uses is pretty much derived from CII's hierarchy. It's very nicely defined in terms of what is in each category, and it's very precisely defined in what's direct and indirect. Very nicely developed system that occurred over about 15 years of development. However, every company's cost codes map into this differently, and every project's cost codes, which are different for every, map into it differently. So there's some real challenges to getting this data. Okay, so I'm really going quickly here, but it turns out that we have access to CI's benchmarking metrics database. There are about 2,000 projects worth of data in the database. There are a couple of hundred projects that have productivity data. So companies are much more willing to report performance in terms of cost and schedule growth and so on, and project practice level of implementation, then they are willing to report productivity. But 200 companies have done that, and so we were able to analyze that data. And what we were doing was we were taking, when CI measures whether you're doing a process like pre-project planning, in the end it's a 5-point scale. Did you do it really well or did you do it not so well? So that's a kind of a degree of implementation. And what we did was we took the high-level practice use projects, we put them in one bin. We took the low-level practice use projects and put them in another bin, compared the differences in productivity between them based on a normalized scale, and said, is that statistically significant and what is the amount of difference? So that would be kind of interesting. The key thing to keep in mind is we're talking labor productivity, work hours on top, because it can be switched around, right? So lower is better. And that's just a CI definition, but also it's been normalized to a 10-point scale because you can't give absolute numbers, that's proprietary, and we want to hide the source of the information. Okay, so the really interesting thing to me, one of the things I was really interested in, and I'm sure Coreworx is really interested in because it's an integration company, is the difference between those projects that had a high degree of integration and automation and those projects that had a low degree of integration and automation. Statistically, there's a relationship that says that where you have a high degree of integration, you on average have about a 45% higher productivity, labor productivity. It's not telling you cause and effect, it's just saying that there's that statistical relationship that exists. Really interesting, then we drill down to the different trades, and it kind of holds for the different trades. I should have the numbers of projects here. It's about 97 projects, and there were usually about 30 to 40 or 50 in each bin or each group. So high levels of statistical significance, but obviously some scatter. Okay, so that's really, really interesting. It's interesting if you're a company thinking about how much you want to invest. It doesn't give you a benefit cost ratio, but it does tell you that there's this, and the numbers are roughly the same for cost and schedule performance as well. You get the same kind of results if you look at high and low levels of integration implementation. Okay. Why I cared about this was because I was always developing automation tools and robots and stuff, and I had a heck of a time convincing funding agencies that they should invest in this stuff. We then drilled down into each trade, so we're looking at each trade each year because there's a lot of statistical analysis involved. In the first year we looked at electrical, then I believe we looked at mechanical, this year we looked at concrete, and next year we're going to look at steel. We looked at the CII practices, and I apologize for the size here. This is integration, safety, materials management, automation, constructability, and team building. And what it's showing is that you can see the numbers of projects there too. What it's showing is that that there's a very significant difference in productivity between high levels of implementation of these practices, such as safety, materials management, team building, and productivity. So you got a good relationship there. Often 20, 30, 35% improvement. When we looked at concrete, FEP is front-end planning. As you know, we got the same sorts of relationships based on quite a number of projects. And then when you roll it all up to the highest level, so you say, so here's these practices, safety, system integration, materials management, which ones of these correlate to really significant improvements in productivity for which trades? And you see that safety always seems to correlate with high, you implement good safety practices, you've got a real big difference in productivity. Could just be because you're a good, sophisticated company that does everything well, right? But there's a correlation. And it's really interesting that systems integration also runs all the way across, as well as team building. Just because something's not in there, it doesn't mean that there's no relationship. It just means that the statistical significance wasn't good enough for us to put it there yet. And maybe when we get more projects, we'll be able to put it there. Okay, so that was the international level, the industry and project level, which practices seem to work to improve productivity and performance based on the data. Then we're drilling down to the project level. What sort of continuous improvement process can you implement, or things can you do, innovations at the project level to improve productivity? And yes, it's reactionary. You shouldn't have to do this kind of thing, but if it has results, then empirically you'd be foolish to not do it. So there's a fellow here, Janica Rampur, he's a professor, works with COAA, and he's done some really interesting studies that are very similar, very closely related, and he's looking at improving wrench time, and he's got some very similar numbers. So I'm going to just introduce a different take on that. Okay. Activity analysis is a continuous improvement process for improving direct work rate. Typically, I think you want to go medium to large projects, and it helps you improve by applying it in a sequential or iterative manner. So you have to plan the study, and that's very important. You have to choose which trades you're going to track. You have to divide the project into areas. You have to think about how you're going to divide the types of activities. You've got to go out and do the sampling. We're doing that right now on continuing to do this research. It takes 3 or 4 days on a project. It takes a week to write up the report. So you've got to do the analysis. Then you sit down with the project management team and you say, based on what we learned, maybe where can we do some improvements? Is there 25% of your time is travel time? That seems like a lot. Let's look hard at how you've laid out the site. Let's look hard at at what's happening, how you're planning the work phase planning. What can we do to improve that? And then you got to go back to the project again a couple months later and measure your improvement to see if you've made a difference. So how do you do it? We categorize activities into 7 categories because it's just easier when you're out on a site. You've got different trades and you've got different categories. When you're walking through the site, to be able to identify what somebody's doing, I do about 7 categories really well. If it gets beyond that, I find it hard, and so do my students. Somebody who's full-time job could probably do many more categories. So you've got direct work or wrench time. You've got preparatory work, which some people would say is productive, but it's not direct. It depends how you look at it. You've got tools and equipment. Basically, you're moving things around. You're moving your tools. You're moving your welding equipment. Materials handling. You're picking up rebar. You're moving that to the work face. Weighting. You're on a welding crew. A lot of times you're paying attention, but you're not directly making things happen productively. Travel is not productive, though. You can't ever say that's productive. Personal time. You've got to do it. If you've worked construction, you got to take personal time. You got to go to the bathroom occasionally. You got to get some water if it's hot. So that's going to happen. But to what extent should it happen? So you go out and you measure all these things. The way we do it is we use a form. We do it by hand with a clipboard. There's a lot of good practice that you need to apply. You've got to talk to the craft workers before you do anything like this, or they'll be very upset. It's really, you're not looking at the craft workers. You're looking at management's processes, and you need to explain that and explain to the craft workers. We're not identifying people individually. We're just trying to figure out how we can facilitate your work better. So what do you get out of this? You get a report, but also you get something like this roller coaster chart, which shows you over the course of a typical day on the project, what is your direct work rate? It shows you things like ramp-up time at the beginning there. It shows you things like break time in the afternoon. And it shows you, if you get good at this and you know what the target rate should be, it shows you where you're really off the target. You're never going to get direct work rate up to 90%. Well, unless you're a lean construction person, then you believe you will. But there's probably a reasonable target. But you probably can improve it. And what we found based on a statistical analysis of 26 project data points and 16 different projects was that on average you can probably improve at about 15% from one visit and improvement cycle to the next. So it's direct work rate or wrench time. That's not labor productivity, but it may be related. And how did we base our study? Well, we went out and, as academics, we did 6 projects ourselves. It was important for us to really understand how this is done, but it's done by experts at companies like Fluor and Bechtel and consulting companies. And they have vast tables of target rate data for different types of projects and different conditions. And when we gathered the data from the CI research team and analyzed it, statistically you can show that there is a significant improvement that you can make by applying this method. On Dr. Rampura's study here, he showed a 50% improvement rate. That was one project, and that we saw 50% improvement rates on some projects, but on average about 14 or 15%. So, final observations. So I started at the macro international level, drilled down to the project level. At the international macro level, after all that, I'm really skeptical of international comparisons because even unemployment rates, they're measured differently, right? Completely different measurement rates. So when you're comparing them, you're really not comparing apples and apples.
And the average is high.
Yeah.
A lot of statistically interesting things. So you can't really look at the averages and draw too many thoughtful conclusions.
Thanks. So despite putting that up and having a lot of fun with it, I'm really skeptical. But I still believe the data doesn't indicate that because you're good now, you can't get better. There's no data to prove that. The data seems to indicate that, in fact, you can continue to improve. And there is really good data that I never was able to share from the World Bank that shows there is a direct relationship between wage rates and labor productivity, but that could be related to substitution of capital for labor. It becomes economical when you have high labor rates. So it's maybe not a cause and effect thing. At the industrial level, getting labor productivity data really, really hard, and programs fizzle out because once you've got the conclusions that we had up there, companies tend to lose interest. Okay, now I know, why should I continue to participate in this program? But also getting them to submit the data is really hard. But we are able, based on the data that we have, to derive statistically significant relationships between certain management practices and productivity and project performance. And that's something that didn't exist until the last 5 or 10 years. There just was not the scientific basis for that. But the question arises, a lot of companies are kind of frustrated. Okay, we know that now. How do we use it for continuous corporate improvement? How do we do gap analysis? How do we figure out where and what practices to improve and why, and the benefit cost analysis and stuff like that. And then the activity level analysis, it's 40 years old. You can argue it went back to the 20s. There was tons of research in the area. We didn't contribute anything except the statistical analysis at the end, because there was no statistically valid analysis before that showed the relationship between activity analysis and improvement in direct work rates. There was anecdotal evidence, there was case studies, but there was no large body of data. But the information out there seems to indicate you can improve direct work rate. There's no study that shows a relationship between labor productivity and direct work rate, though. As much as we intuitively believe like there should be a relationship, there's no study that statistically proves it, and every time academics have tried, they failed. So that's just a really interesting point to conclude with from my point of view. And the reasons, maybe you're really busy doing rework. Maybe you're really busy doing things really badly. So direct work rate isn't necessarily the panacea, or wrench time isn't necessarily the panacea. Okay, thank you very much. I open the floor for questions.
Thanks again, Carl. Anybody want to challenge Carl, ask any questions, any comments?
Yeah, Carl, I guess the improvement you're measuring the second time is totally dependent on your effort. There's no feedback. They don't have a feedback tool to...
You know, you're making the assumption that it's based on the changes that you made to the project processes or layout or environment. Maybe you just moved the porta potties closer to the work face. You know, but yeah, it's based on that assumption, and it could be wrong. That's why you need a lot of data.
One of the big changes that nuclear made in this next stage of building is the regulators requiring all the suppliers to have a corrective action process. Before, it was optional. It's not optional anymore. And so you're really going to be able to tell how improvements happen based on self-driven demand of making mistakes. And it doesn't mean you can't come in and do an observation, but it causes them to be more introspective of their work.
Okay, thanks. It's interesting. So it reinforces that finding then, I guess.
So CII had, all the owners said you needed to have some kind of feedback process that you could collect data from. That gives you an audit capability at any time without even going to the facility.
Okay, thanks. Yeah, that's a great suggestion.
Do you ever see a time when companies will have common benchmarks that us operators can ask them for so that we can judge their performance and productivity?
There's a effort called ASTM, right? And there's an effort between them, the National Institute of Standards and Technology in the U.S. and CII to put together a large working group to come up with standards. I think it's possible, and I'm optimistic fundamentally. I invest optimistically. I'm all in stocks, but I'm skeptical that it'll be a long time, in my opinion. Yeah.
We should do our own man.
In Alberta. Alberta is doing really well in that regard because the owners are so well coordinated. Yeah. Alberta's leading the world in many ways.
Anyone else? Thanks again, Carl.